Welcome to myprojectbazaar.com. The project title is Spectrally Precoded OFDM without code insertion. The project abstract is the proposed spectrally precoded NG OFDM, that is SP-NG OFDM system can provide channel capacity very close to non-precoded and spectrally precoded OFDM using the cyclic prefix, that is CP OFDM. When the removal chord ratio is small and much higher channel capacity per unit bandwidth than spectrally precoded CP OFDM, conveying the same data rate provided that a small out of band power proportion is required. When a sufficiently small precoding rate is adapted, the SP-NG OFDM receiver using chord removal and LMMSE FDE is also shown to counteract ICA efficiently and exploit frequency diversity over dispersive channel. The project flow diagram is to estimate and detect the OFDM without chord insertion. Initially we calculate system model. It is based on OFDM. It means orthogonal frequency division multiplexing. Next we have to remove the chord insertion of our OFDM for precoded signal. In that precoding we have to follow these three methods. First one is chord removal of OFDM in bandwidth, and second one is OFDM modulator to modulate the signal, and third one is to apply the demodulator for OFDM. So these three methods are going to precode our signal. So finally estimate our detected OFDM without chord insertion. Our project source code was run from the command window. In current folder shows our main file, so we have to run our main.m file. So it is our source code file. So we have to right click the main.m file to run. So initially we have to calculate the bit error probability, that's going to shown on the command window. So it is our final graph. In figure 1 shows that the cumulative distribution function, that is CDF plots of PAPR 128PT FFT using BPSK and QPSK. According to that color, the BPSK and QPSK signals are shown. It is going to real and imaginary value. In X label shows the PAPR in decibel, and Y label shows that the probability. So it is the graph for our CDF plots. In figure 2 shows that the cumulative distribution function, that is CDF of characteristics of PAPR for various NG OFDM and CP OFDM. It is the unicoded signal 6 equal to coded, and unicoded signal 10 is coded, and unicoded signal is 14 is coded. So in our U6 it is our coded signal. So our proposed work is compared to our U14 coded. So in X label shows the PAPR and Y label shows the probability error. In figure 3 shows that the eigenvalue to find our non-precoded signal. In X label shows the index and Y label shows the eigenvalue. So it is based on CP OFDM system and NG OFDM system. It is too common for both to calculate the non-precoded signal. In figure 4 shows the eigenvalue of AX for various NG OFDM and CP OFDM. So it is also calculated the coded signal to U3, U5 and U7. So it is the variations of our coded signal for U3, U5, U7. X label shows the indexer value and Y label shows the eigenvalue. In that figure shows the table value of our U3, U5 and U7 for eigenvalue of CP OFDM and OP OFDM. So it is the value to calculate our OFDM of precoded signal. In figure 6 shows that the channel capacity in bits per second for various NG OFDM and CP OFDM system. So according to that channel capacity, the curve will be like that. So our CG OFDM got interval like blue color line and NG OFDM got removal is red color line. In X label to calculate our alpha value and Y label shows the channel capacity. So in figure 7 shows the non-precoded CP OFDM with LMMSC. So it is to calculate our mean square error of our precoded signal. So the 4 lines are enumerated to our legends. So it is according to remove the Godband interval and iterative cancellation and part elimination and LMSC calculation. In X label shows the comma S and Y label shows the average bit error rate. So the project demo was completed. Thanks for watching this video.